Hello, good afternoon, everyone. Welcome to the GATE Academy, GATE's core booster session of Geotechnical Engineering. So please let me know who all are there. So this is the second part of Geotechnical Engineering. We have already completed the first part. So those who have missed the first part, don't worry. The video is available in our YouTube channel. You can just watch it later. Okay, so today we are actually continuing the first session, but we are actually discussing completely new topics. So those who have missed the first part, don't worry. You can just watch this, attend live. Later, you can go back to the YouTube channel. So there you will be getting the part 1. Okay. So please let me know who are there. Rajani, Srikanth, Krishna, good afternoon, everyone. Khushbu is there. Sorry if I missed any name. Right. So I hope majority of you have already watched the first part. First part is actually the fundamentals of our geotechnical engineering, right? I told you it is the foundation. So if you are very strong in the foundation part, if you are very strong, if you are very confident in that first part, then definitely you can do a lot of questions very easily. Easily you can understand the question, what they are asking and okay. Kursaj, you will see that, don't worry. Regarding seepage and all, we are going to see in the second part. Okay, so are you ready? Shall we go to the first question then? Okay, so those who have missed the first part, I can tell you something. The agenda behind the session is nothing but we are going to do a lot of questions. Through the questions, we are going to revise geotechnical engineering. Okay, that's what we are doing. It's not like simply solving a lot of questions. I mean, it's not about the number of questions that we are solving. It's like how much discussion we are making on each question. Okay, so by solving the question, I will tell you a lot of concepts. Like that, we are going to revise the geotechnical engineering subject. Okay, so we are going into the first question. Yes, so take this question. Take this question, everyone. Just understand what you have to do. Understand what you have to do. Then I will explain once you start solving it. Okay. I'm giving you a few seconds to understand the question and solving it. You know the effective stress formula. Effective stress is equal to total stress minus pore water pressure. Okay. So slowly do it. Understand what to do. Yes, the answer I will tell you after some time. Kasturidas, you please check your answer again. Slight mistake is there, I guess. See, once you are getting an option, I mean, once you are getting a value and you are looking at the options and you are seeing the same value in the option, doesn't mean that it will be a right answer. Okay. I have made the options in such a way that if you are making a mistake, what you are going to get, that also I will be keeping in the option. Okay. Purposefully, I'm keeping like that just to let you know that whatever your calculated value may not be the right answer. Okay. Yes. Shall we solve it? Yes. Okay. Now what we have to do? We have to calculate the effective stress at point P, right? That's what they have given in the question. Now where is point P? It is given there, which is at 2 meter. Now above that bottom layer. I'm taking this as the bottom layer, 2 meter above, right? So how can we calculate simply? Above that point, whatever is below that point, we don't care. Whatever is above that point, we have to check the total stress and the pore water pressure. Okay. Now what we need to calculate, how much will be the change in effective stress? Change means they are telling if capillary rise occurs. So before capillary rise, what will be the effective stress? After capillary rise, what will be the effective stress? We have to take the difference, as simple as that. Clear? So before capillary rise, how can we calculate? See what is happening due to capillary rise? The soil will get saturated. Now, that is the only change. The water table is not changing. Water table remains in the same position, but the soil will get saturated due to this capillary rise. Understood? So for pore water pressure, we will not consider that rising. Only for total stress, we'll consider that rising. Very important point. So first of all, we are just considering without capillary rise. So what it will be? The total stress will be the stress due to this 3 meter, which is dry soil. Gamma D is not given. We have to calculate. We have already seen how to calculate gamma D in the first part. Okay, we have the equation gamma W into G divided by 1 plus E. Using that equation, we have to calculate the gamma D value, gamma D into 3 plus what about this portion? What about this portion? That is of 2 meter, no? 3 meter, then 2 meter. Total sand layer is 5 meter. So will that portion will be under dry state? Should I take dry density or should I take any other density? Very good. Obviously, saturated density I have to take for total stress, and for submerged I have to take for effective stress. Okay. So that part I have to consider plus another value. So till here we have different soil. So again we have to calculate the gamma value, but here they have given directly the gamma saturated value they have directly given. Okay. Only thing is you have to remember above the water table we are considering dry. Below the water table, we have to consider saturated. So that in the effective case, saturated minus gamma W will come gamma submerged. Okay, I have given enough hint. Now you start solving it. Start solving it. So before capillary, no need to look at the screen. You can just solve yourself. Sigma Z is equal to, see, either you can simply put it as total stress minus pore water pressure, or directly you can put also. Or simply if I'm putting separately, you can just compare your step, understand where you made mistake. So gamma saturated we have to calculate now. Gamma D also we have to calculate. Okay. For the sand layer, just calculate yourself. Tell me how much it is, everyone. Please tell me how much is gamma D. Can you please comment, everyone? How much is gamma D? Everyone please comment how much is gamma D. 17.65. Okay, thank you. So gamma W into G divided by 1 plus E. G value is given, E value is also given. So 17.658. Okay. So which unit? Kilonewton per meter cube. Na? In which unit you are substituting your gamma W? That will be the unit here. If you are taking 9.81, then kilonewton per meter cube. Similarly, gamma saturated, what we have to do? G plus E divided by 1 plus E. Na? So tell me how much is gamma saturated? 20 exactly. Tell me exactly. 20.928. Okay, thank you. Same unit, na? Kilonewton per meter cube. Okay. So gamma saturated we got, multiply with what value I have to take? The entire depth is 6 meter, but they are asking for the point P, which means above P, how much thickness of clay we have? 4 meter. Out of 6, 2 is below, so 4 is above. This is what? This is the total stress. From this, we have to minus the pore water pressure. What is pore water pressure? Whatever is the depth of water under the water table. So here is our water table. So 2 meter in the sand, then 4 meter in the clay layer above the point, wherever we want to calculate. So either you can directly put gamma W into 6, or I'm simply putting gamma W into 2 plus gamma W into 4. So this part I have to deduct from the total stress. So if they are asking total stress, it is the first part, pore water pressure, the other one. Okay, if you are substituting, how much you are going to get? Everyone please tell me. Yes, or directly you can put gamma D into 3 plus gamma saturated minus gamma W is nothing but our gamma submerged into 2 plus again gamma submerged into 4. Very important. This is for sand, this is for clay. Okay. So this is for the sand. This is for the second layer clay. Tell me how much it is, everyone. Please calculate and let me know how much you are getting. $109. Akshay, I will come to you later, don't worry. 109.97. Enough? Okay, so this is the value. This is the value. See, this is stress. So kilonewton per meter square. If they are asking in some other unit, properly change it. Okay. Gram per centimeter square, something like that. May not be asking in that unit and all. Properly check it. Okay. Getting everyone? Yes. Now what you have to calculate? What will be the effective stress after capillary rise? So due to capillary rise, what is happening? They told that the capillary rise occurs up to a depth of 1.5 meter above water table. Means right now water table is somewhere at 3 meter below the ground level. Now they are telling 1.5 meter is rising, up to a depth of 1.5 meter above the water table. So this much portion is getting saturated due to capillary rise. This is what is happening. So a rise of 1.5 meter. Now what will happen in our new equation? Gamma dry portion will be only in the above 1.5 meter. Then that yellow shaded portion also will become saturated. So in the equation, what change will come? Here, instead of gamma saturated or gamma D into 3, it will become gamma D into total 1.5, top 1.5 only. The remaining 1.5 got saturated. So that 1.5 will come along with this gamma saturated value. The other changes in the pore water pressure, gamma W, we are not considering the capillary rise. Okay, in the gamma W portion, we are not at all considering that portion. We are not counting that portion. Okay, but if it is coming in the capillary region, then we have to consider that. I will tell you. So calculate it and tell me how much you are getting. So this is submerged. Okay, submerged. So yes, very good. Pore water pressure will not be considered. Yes, you're correct, Naresh. So tell me how much. What is the step? Gamma D will come only for 1.5 meters. Then it is going to be our gamma saturated value. How much gamma saturated? If I'm simply separating it. So the remaining 1.5 is getting saturated. Then it is same into 2 plus again we have gamma saturated into 4. Only thing is these things are for the sand layer. No, this is for the sand layer. This is for the clay layer. Okay, one I am representing for sand. Now minus gamma W into that remains same. Okay, it will not change the gamma W value. I mean that pore washer pressure you should not be changing. If they are asking, if they are telling that capillary rise is happening. Okay, tell me how much it is, everyone. Please calculate and tell me. We're getting around 114 something. Everyone please comment so that I can compare my answer. If you're telling the same answer, please let me know. Or you can just comment your answer. Yes, thank you. Now what we need to calculate? How much is the change? So tell me how much is the change then? Change means it can be plus or minus. Okay, if it is a numerical answer type, then they will give minus also in the answer key or plus also in the answer key. Means both they will give, both will be accepted. Okay, whenever they are asking you the difference, you can simply put the positive value. That's it. Getting now? Yes, thank you. Now what will be the change then? So we understood that, okay, it is increasing. So 114.875 minus 109.97. 4.9, okay, around 4.9 kilonewton per meter square. Yes, very good. Krishna, Pragai, okay, Srikanth, all are getting now. What is the gamma W value? How much is gamma W? We have discussed in the first part now, not remembering. Unit weight of water. It can be 1 gram per cc, 1 gram per centimeter cube. It can be 9.81 kilonewton per meter cube. It can be 9.81 into, sorry, you can also put it in Newton, means, yes, into 1000, okay? That is equal to 9.81 into 10 raised to 3 Newton per meter cube. It can be 1 tons per meter cube. Anything you can substitute. Only thing is in which unit you are substituting your remaining value, or in which unit you want the answer. That's it. In the question, in the options, they have given everything in kilonewton and meter terms. So we are going to substitute. Where is kilonewton and meter? This one. Okay. So kilonewton per meter cube multiply with 1.5 and all is in meter. Meter cube and meter will get cancels. We are going to get meter square. Clear? Okay. Don't forget these things. Very, very important thing. This is why I told the first part is more important. Foundation. Clear? Okay. Very easy. So only thing is, if they are not giving you the gamma D value or gamma saturated value, we just have to calculate from the given data. They may give the void ratio. See what is this E and G and all. I hope you already know. We have discussed these things in the first part. That's why I'm again not discussing. E is the void ratio. G is the specific gravity. Using that, we have the equation. We have seen this equation before. And using the equation, we are going to calculate it and substituting. Okay. Ragai, do one thing. Later, this video will be uploaded in our channel. You can watch that. Then you will be getting the explanation from the beginning. Okay. If I'm again going back to the first portion and again discussing, we'll lose so much of time. Okay. Okay. No, don't worry. This video will be getting it later. Understood? Now see guys, if they are asking within the capillary rise portion, then what you will do? Means right now they asked in this portion, na, P. So at P, there is no capillary action. At that point P. Capillary action is happening in that 1.5 meter portion. If they are giving you any point, see somewhere here, Q. They are giving a point Q somewhere like that. Okay. Or here at the top, another point R. So in that capillary region, if they are asking what is the effective stress, then what you have to do? Then you have to consider that portion in the pore water pressure. How much it will be? The pore water pressure will become a negative. See, here it is a positive value. That positive value, we are going to take it into action. For example, if I am simply telling you that you can do it as a homework, the data the value I don't have. Suppose if this is the 1.5 meter depth, okay, simply, or if I'm telling in general case, suppose if this is the H value, that capillary rise portion, okay. Now, if I am drawing the capillary, if I am drawing the effective stress diagram here, in this portion, how we'll be getting it? We have the water table here. We were having the water table, just compare with the previous one, okay? We have the water table here. So generally, we are not going to draw, we are not going to consider the pore water pressure at any point. Nah? Here it was our P value. So we have considered, see something like this. This is nothing but our gamma W into 2 plus gamma W into 4. And that corresponds to this P. Now, if they are asking in this capillary region, I'm sorry, I made a mistake. It's not like this. See from here. Okay, here is our water table now. So like this. So if they are asking in this capillary region, we are going to extend this little bit. So it's not simply extending like this. We are going to draw a pore water pressure here. So it is in the left hand side, means it is negative. Here the value is positive value. 9.81 into 2 plus 9.81 into 4. It is a positive value. Here it is negative value minus gamma W into H. Understanding? Is it clear, everyone? In the sense, if they are asking you the effective stress, total stress portion is same, means this first part is same. In the second part, what will happen? If they are asking in this region, we don't have any gamma W there. Above water table, we don't have any water table. We don't have any water. But if they are asking in that portion, what we have to do? We have to consider a stress diagram like this, pore water stress diagram like this, which means when we are adding, suppose you calculated, okay, let it be. what I can tell. Okay, leave it. Are you understanding what you're doing? Understanding what we are discussing? So this value will be 9.81 into 1.5. So if they are asking at any point, suppose this was our point Q, suppose this is our point, so let it be R and Q. If they are asking at this point, what we have to do? We have to calculate the density gamma D into 1.5 minus pore water pressure is going to be minus gamma W into 1.5, like that. Is it clear? Clear? So I'm just giving you a homework. What you can do later at the end of the session, you just calculate it and comment in the comment box. I will tell you whether your answer is correct or not. What you have to do? There are 2 points. One point is R, which is at that 1.5 meter depth. We have the capillary rise till 1.5 meter. So at that end, okay. So there is our R. Then Q is again at the middle of that capillary rise portion. In the sense, if I am drawing that, this is 0.75. Are you understanding? In the middle of that capillary. Okay, Niru, I will come to that later. Don't worry. Okay. So you just do that. What is the effective stress at R and what is the effective stress at Q? Both answers you calculate. I don't have the value right now, so I cannot tell you. So you calculate it later. Comment in the comment box. I will let you know there. I mean, once this video is getting uploaded in the channel. Okay. After this session, it will be uploaded. Is it clear? Okay. Only in the capillary portion we are going to consider it. Clear, guys? But if they are asking outside the capillary area, we are not going to consider that portion in the pore water pressure calculation. Is it clear? Yes, very good. Okay. So I'm going into the next question. Yes. So let's see this question. No need to solve it completely. Just understand what is the change in this question. Just understand what is the change in this question. Everyone. What is the change? Is there any difficulty in this question if they are asking? This is actually previous GATE question. GATE 2011 question. So we are not going to solve it. Just understand what is the change here. During our TGA live class and in the doubt solving portal, if you are a TGA student, the GATE Academy student, you are going to get a doubt solving portal. So in that also I got this doubt a lot of times. Yes. So what is the change here? Sea water is coming. See whether instead of fresh water, by default we are assuming whenever they are giving water table, we are assuming that it is fresh water. Gamma W equal to whatever we have written. You know, as of now, gamma W values. Whenever it is a sea water, or they are telling that there is a soil which we are saturating by kerosene or any other solution, if they are giving anything else other than fresh water, then our values are going to be changed in the equation. Understanding? So what we have to do, just remember a shortcut equation. We can solve it by taking some 3-4 minutes, but just within 30 seconds or 1 minute you can solve this. Just remember this shortcut equation. Gamma saturated will be equal to, if it was a fresh water, what is the equation? Gamma W into G plus E divided by 1 plus E. And in general sense, if it is a partially saturated means gamma W into G plus E SR divided by 1 plus E. This is our general equation. What we can do if it is 100% saturation, if S is equal to 100%, the equation is going to be like this. Okay. So under sea water means what? We have soil here, or let it be, this is sea water. We have soil here, okay, inside a sea, or we are completely making it saturated. Then SR is equal to 100% in this case also. What small change you have to make? If it is 100% saturation, gamma W into G plus E, what you have to do now? We just have to multiply with specific gravity of that particular solution. Means let it be a sea water, let it be kerosene, whatever. We just have to do that. You are going to get the answer of gamma W. Understanding? So if it is partially saturated, then also no problem. In this equation, you have to again multiply with the specific gravity. Okay, understanding? Now see guys, here we have to calculate, okay, just I'm telling something. What will be the effective stress at 30-meter depth into the sand layer? Means we have seawater of so much depth. Here we have soil. So this part is completely soil. One second. So this part is completely soil. Okay, whatever I'm showing here is soil. They're telling what is the effective stress at 30-meter into the soil. So generally what we have to do, at this point, we know gamma submerged into 30 we have to take. So how can it saturated value I told you? How can we calculate gamma submerged from this? Gamma saturated minus gamma W. Are you having any doubt? Are you having any doubt? Is it clear? Any doubt? There should be a doubt because this is wrong. Why? We have already discussed that gamma submerged is equal to gamma saturated minus unit weight of that. Yes, whatever solution is there. So if it is a seawater, we have to take seawater there. Clear? Is it clear? In the sense, if you want to solve it, you can just fastly solve it and take the answer, no problem. What will be the answer? See, in this question, I told you before in the first part, instead of giving you, I told you to remember relative density. So what they have done, they have not given the void ratio. Instead of that, they have given the relative density, maximum void ratio, minimum void ratio. From there, how can we calculate E value? Yes, everyone please comment. Tell me how much will be the E value here. Void ratio, everyone please tell me. We have already seen this equation in the last class. We have already seen this equation in the first part. Those who missed the first part, you have to watch that first part. Yes, very good. E is equal to 0.8. See, this is why I told you, you have to remember relative density equation. Either they can ask you as a question, or like this, they can use that concept inside a numerical question. Clear? Yes, very good, very good. I'm happy that all are commenting. Now see, we got E value. Now how can we calculate the saturated now? Just substitute and tell me how much you are getting saturated value. Substitute and tell me how much is gamma saturated. Everyone, gamma saturated is equal to, see here it will be gamma W, don't change that, G plus E into its completely submerged portion. So SR is equal to 100%. Then specific gravity. How can we calculate the specific gravity? They have given in the question directly, I guess. 1.03. Specific gravity of seawater 1.03 directly given in the question, last sentence. So tell me, if you are substituting, okay, 9.81 into G is equal to how much? 2.67 plus 0.8 into 1.03. 1 plus 0.8. Yes. So we are going to get 19.04. Okay. Thank you for commenting. Okay. This much we got. Now tell me how much will be gamma submerged then? Gamma submerged, gamma saturated minus gamma of seawater. Tell me how much it will be? 19.04 minus, how to calculate gamma seawater? How to calculate gamma seawater? We know specific gravity is equal to, specific gravity of seawater is equal to unit weight of seawater divided by gamma W, unit weight of fresh water. Any specific gravity is like that. That's why specific gravity of water is equal to 1. That is given as 1.03, which means gamma seawater will be equal to gamma W into 1.03. Okay. So directly I'm putting it here. 9.81 into, right? So submerged density, how much you are getting? 8 point. Okay, thank you. Correct now? Correct. If you are taking 9.81, you are going to get wrong answer. Vikash, properly check your answer. This is what I told. Okay, 0423, something like that. Better you take accurate answer. Is it clear, everyone? Okay, kilonewton per meter cube. Now, If they are asking for any water course, this is very, very important point. For any water course, we will be having a bed level. Na? Whatever be the depth of water, suppose if the depth of water is still this, maybe the water depth is increasing, again increasing, again increasing, again increasing. Whatever happens, whatever be your depth of water above the bed level of a sea or river or lake, whatever, what will be the effective stress at this location? What will be the effective stress at this location? Very good, zero. Very, very important point. Can be asked. In this case also they have asked, effective stress at the bed will be zero. From here onwards, the effective stress is going to increase. They are asking at 30 meter below into the soil. So how much will be this answer? How much will be this answer? Gamma submerged into 30 meter. Tell me everyone, how much is the answer? Everyone please comment how much you are getting. Very good, 268. Getting 268 around 8.92938 into 30. Are you getting approximately 268 kilonewton per meter square? Correct? Yes, very good. Now you understood how simple this question is. Kilonewton per meter square is equal to kilopascal. Okay. So option C is going to be our right answer. Is it clear, everyone? Everyone, please comment in the comment box. Is it clear? Yes, very good. Okay. Now you understood how simply we are going to calculate. They are giving something else. The actual procedure is actually lengthy. We have to calculate a lot of things. Confusion will come. Okay, that's all. Not that much lengthy. So much confusion will come. Now is it clear? Yes. Now tell me what is the answer of this second one. I have just directly snipped this question from the question paper. Tell me what will be the answer of the second one. Everyone please comment in the comment box. Yes, very good. That's it. Understood. So whatever happens in the water table, I mean above the bed of the sea or bed of the river or bed of the lake, whatever happens, effective stress is going to be zero. That can be asked, okay, easily. Clear? Yes, very good. Understood? Now I'm going to give you another concept, something related to seepage and all. Okay, just read this question and understand. Do you know how to do such question? This is another point where I generally used to get doubt. Just understand what we have to do. Please read the question properly, everyone, and understand what we have to do. I'm giving you a few seconds to understand the situation given in the question. Yes, got it? How we started solving it? Now I will tell you the concept, okay? See, heaving is actually nothing but if the water is actually going into the soil layer due to seepage or capillary action, anything. So what will happen due to the seepage or capillary action and all, the pore the pore space will getting saturated and the capillary fringes will it will be having the water. So later when this temperature decreases, the water will get freezed. So that is nothing but we call it as heaving, soil heaving and all. Okay, somewhere you might have seen that word heaving. Yeah, no heave will occur. Nothing, somewhat similar to our quicksand condition and all. We have to finally consider our effective stress concept and all. Effective stress concept that is equal to zero, that concept. Okay, so if later when the temperature increases, this water will melt also, somewhat related to freezing and thawing you might have studied, somewhat. If you are seeing quicksand condition or if you are seeing heaving or heave condition, just always remember we have to equate the effective stress equal to zero. Okay, this may not be due to seepage and all, this can be simply due to the capillary action also. Okay, so we are going to consider gamma saturated value and we are going to solve it. We can calculate it by taking gamma submerged also. But when we are calculating gamma submerged, generally students used to make mistake. So I'm telling the simple thing, okay, using gamma saturated, how can we solve such a type of question? This is very important concept from competitive exams point of view. What they are telling, there is a soil. In that soil, we have to make a dig. We have to make a dig. So in that, how much we can excavate so that there will not be any heaving happening. So they are telling that it is a 12-meter thick soil. So if I am simply drawing it, so we have a 12-meter thick soil. So this is our soil. In this, water table is also there at 1.5. If water table is not there, then we'll take gamma D and all. Okay, simple as that. So 1.5 meter. Okay. Now, what they are telling, we have to make it. We have to make an excavation. Okay. If I am making an excavation here, see somewhat like this, there is chance that heaving may happen at this bottom of the sand. So right now we have sand like this. Till water table we have saturated sand. So this is sand only. Okay, don't confuse with water table. Below here also we have sand, but we don't have sand here at this excavation portion. One second. So here and all we have sand. Yes. Now see, if we are considering this point, how much will be the effective stress here? Exactly below the excavation, how much soil we have, that much portion we have to consider. So this is the portion under our consideration. So what we have to do, whenever they are asking how much can be the maximum depth of excavation, they will be giving you the void ratio, they may be giving you the specific gravity, whatever they are giving, what we have to consider, we don't have to consider what is happening above or here side and all. Only just below that excavation portion, we have to calculate the effective stress here. Under quicksand condition or under this heaving portion and all, at critical location, we'll assume or not assuming, at critical portion, we have to take gamma effective is equal to or submerged. The effective stress is equal to 0. Okay, so what we have to do, simply if I'm substituting 0, what it will be, we just have to take the portion here. So gamma saturated into, if I'm putting this height as h, gamma saturated into h minus gamma w into, how much will be depth of water table? This one, I'm just putting it as hw. Okay, height of water. In this case, how much it is? Okay, let it be. General case, I'm putting hw will be equal to 0. That's it. But what we have to calculate, we want to calculate this depth of excavation. How can we calculate it? If you are getting this h value, 12 minus h is nothing but that depth. So that's it. So do it. Gamma saturated value we have to calculate from this. They have given void ratio, everything is given. So calculate it. Definitely that portion is underwater, underwater table. So degree of saturation SR will be 1. So calculate gamma saturated and tell me how much it is. Tell me the gamma saturated value, everyone. Yes, very good. See, no need to calculate exactly how much it is. Why? Because gamma saturated we know gamma W into G plus E. SR is equal to 1 plus E. You can simply put gamma W there. No need to calculate it. Because gamma W is there here also. What I will get? Gamma saturated into H is equal to gamma W into height of water. Gamma W will get cancels if I am substituting in terms of gamma W. Up to you. So tell me how much you are getting. Everyone please comment. Divided by 1 plus 0.6. If I'm simply putting gamma W there, I will be getting something like this. Okay, it's up to you. You can either calculate or you can put it like that. Into H is equal to gamma W into height of water table will be 12 meter minus 1.5, 10.5. Very good. How much? 5.1219. Okay, very good. So H is equal to 5.1219 meter. Okay. So is that my answer? No, they're asking what can be the maximum depth at which excavation can be made. So how much depth we can make? Yes, very good. Kasturi, that's very good. How much depth we can make? Depth will be equal to then 12 meter is the total. 1219, 6.878 meter. As simple as that. Understood? Is it clear? Okay. So if they are asking, we can take gamma submerged, then also we can calculate. But finally, you will get confused. So I'm not telling that. Simply remember, whenever they are giving a soil profile and asking you what is the maximum depth up to which we can make an excavation. See, similar to this, there is another concept that we are going to study later. What is the maximum depth of unsupported excavation? What is the maximum unsupported excavation possible without any lateral support? That we are going to study later in cohesive soil. There is a concept without giving any lateral support here. How much depth we can excavate? We have an equation like this. That will be equal to 4 into C divided by gamma root Ka. Like that, an equation we are going to study. Okay, that is different. That is what? Without any lateral support, how much depth we can make so that this soil will not come down. You know, this soil will not come down. That is the meaning. Here what? Here we don't care whether we are giving lateral support or not. Here we are considering for not happening a heaving process. How much should be the depth? So properly remember, okay, simply looking at what is the maximum depth of excavation. Don't go for a particular equation. Okay, check it what they are asking. This is without lateral support. We are going to see that later, maybe in the next session. And here it is. Okay, I'm not rubbing it. Those who want, just check it. Okay. Now that is not required here. That is something extra point. So all are getting 6.8. Yes, very good. To discuss, okay. So many type of question we are going to discuss in the coming time. Now, what about the second one? If the excavation of 8 meter is to be made, how much the water table has to be lowered from the initial position? So what we need to do? What we need to do? We have to make an excavation of 8 meter. Right now, how much excavation we made? 6.878 meter. If you are again excavating more than 6 point, how much you got now? Sorry. Right now we got the maximum depth as, 6.878 meter. If you are again excavating, heaving will happen. The water will come to that location and finally problems will happen. The soil will get collapsed. Okay, volume of what soil will get increased and all. Whenever it is temperature decreases, it will melt. So much of soil problem will happen. If you are constructing a structure above this soil, definitely the structure will finally settle and fail. Okay, simple as that. Now see, now we are telling in the question, we have to make 8 meter, means something more we have to excavate. Now what we have to do? Simply we have to lower the water table. Lower or higher, whatever it is. Actually, we have to lower the water table, definitely. If we have to dig more. So what we have to calculate? If this depth is going to be 8 meter, then how much should be that HW? As simple as that. And we have the relationship. Remember the relation, very important. Remember the relation. Okay. Now what we are telling, as of now, we have calculated what is this H. From H, we have calculated how much is D. Now we are telling, we have to make D is equal to 8 meter. Then in this equation, how much I have to substitute H value? Vaishnavi, check your solution again. Something mistake is coming. Some mistake is coming. Tell me how much is H value. That might be the mistake. Everyone, please tell me how much is H. Vaishnavi, tell me how much you have substituted H value. H value, is it 8 meter? No, it is. Yes, very good. It is going to be 4 meter. H na? Okay, whatever happens. So H is equal to 4 meter. So gamma saturated we got already. Only thing is, instead of taking this 12 minus this thing, we just put HW there. So calculate HW. So how much we have to substitute? According to my calculation, I have calculated like this. Nothing but gamma saturated into 4 meter is equal to gamma W into, simply I'm putting HW. Everything I have, I just have to calculate how much is height of water. If I'm getting height of water is equal to 8.2 meter approximately, yes, very good. Previously we had a 10.5 meter from bottom. Now we have, we understood that it can be 8.2 meter, which means how much we have to lower using pumping out test and all. We have to lower by how much? The difference, how much it is? 2.3 meter, no? Okay, 8.199. Yes, very good. Correct. Hana? Yes. So new height of water, this one, HW is equal to 8.2. So what is the question? The water table has to be lowered from how much? Now, how much the water table? So water table, okay, sorry. Water table has to be lowered. Understanding, guys? Is it clear, everyone? Everyone, please comment yes or no. Okay, in whichever point they are asking. Okay, in whichever point they are asking, they will ask like this only. Okay, at the bottom of the layer. Whichever point they are asking, we can easily check what is the depth of water till that portion and what is the height of soil above that portion, means in that excavation area. If they are giving more depth or more layer and all, similarly we can calculate like the way exactly we calculated in effective stress calculation. Clear, guys? Everyone clear? Yes, very good. So yes, one second. In the previous session that I have to tell you now, in the previous session, we have I told you, just to check this terminal velocity equation. So what mistake we have made there that I told you to check, everything is correct, but in the third portion where we have written this, those who missed the first part, don't worry. This is for those who have already seen the first part, okay? So here we have written gamma W. It should not be gamma W, it will be rho W, okay? Just please change that, okay? It should be rho W. Those who attended the first part, those who have not watched, don't worry, later you check it, you will understand this. Nothing but if you are simply multiplying and dividing this equation with rho W and rho W, what you will be getting? Rho S by rho W will be our G value and rho W by rho W is 1. So remaining is rho W only. Understanding? Is it clear, guys? Density, okay? Not unit weight. So here only we made a mistake and fourth one was absolutely correct only. Clear? Those who have seen the first part, is it clear? Those who have not seen, in the first part, last portion, when we are ending the session, I was telling you to check this, okay? Okay, clear? Yes. Those who missed that first part, don't worry, later you can watch it. Now, if you are going into the next question, yes, 1 second. Yes, take this question, everyone. Understand what to do. Everyone, please read the question properly and understand what to do. Hope you know the concept. Try to do it. After some time, I will explain. Start solving it, everyone. Okay, can I solve? Okay, Gurusaj, don't worry. We are going to make it clear. Don't worry, okay? See, last year also, we have done the gate score booster session. So for all the subject, you can just watch last year video also. It is available in our channel, YouTube channel. Or simply you can type in YouTube, gate score booster session, the Gate Academy. will be getting it. Okay. There also will be getting a lot of questions. Right. Okay. So whenever, see, what is the name of this diagram? What is the name of this diagram? It is known as flow net. Flow net. So what we have to do whenever they are giving a flow net, we have to count the number of potential drop and count the number of equipotential line channels. So what you have to do? So how many channels are there, or how many ND value? Okay, before that I will first tell you what is the equation of that. The seepage flow Q is equal to, this is seepage flow. What is our equation? K into H into NF divided by ND. Now K is nothing but, okay, let me see whether I have written all the equation or not. Okay, after this I will show you some other equations. Okay, one second, let me check whether I have okay, no, I will tell you later. Okay, yes, now see, this is the seepage equation before a particular structure when they are giving you the flow net. Okay, flow net means it's a combination of equipotential lines and like this. Okay, we have to consider how many potential drops are there and how many flow channels are there. What do you mean by potential drop? Whichever is drawing from top to bottom, that you have to check. So these are top to bottom lines, these things, vertical lines, not exactly vertical, simply. So tell me how many drops are there till here? 1, 2, 3, 4, 5, 6, 7, 8 and 9. You have to check from the starting to the top ending. 9, yes. So that we count it as number of potential drops as 9. Understood? Understood what we have done? Understood what we have done? According to the given figure, you have to take it. So like this, 1, 2, 3, 4, like that it will go. Okay. Hope you understood. One second. Okay, let it be. I think my system got some problem. Okay, let it be. 1 second, guys. Give me a second. Give me a second, okay? Please wait. Yes, I hope you can see the screen now, right? Okay, now see what you have to do. You just have to count how many drops are there. We got that is equal to 9. How many flow channels are there? Flow channel means what? That space in between the lines. How many? If you are checking below, how much are there? We have 3 lines. 3 lines means how many flow channels will be there? 1, 2, 3, 4. 4 spaces. Are you getting it? Yes, very good. NF is equal to 4. Clear? ND means how many drops are there? You have to count all the lines till that last portion, till that horizontal portion. Flow channel means in between that horizontally going lines, how much spaces are there? So 1 space is here, 2nd space, 3rd space, and 4th space. So we got ND is equal to 9, NF is equal to 4. Okay, so till that we can directly substitute. Now K is given, K is not given in the question. We have to take, 1 second. Okay, so K is not given in the question. We have to take it from the options. We don't know right now what it is, but it is given in the question that the seepage flow is happening. The seepage flow is happening, which is equal to 8.5 meter cube per second. So the answer is already given. We have to calculate the K value there. 8.5 meter cube per second, which is the discharge. K value we don't know. How much is H value? Should we take 6? Depth of water should we take 6? We'll take 6 if there is no downstream water table. If they are not giving any depth of water at the downstream portion, means sometimes instead of giving like that, they can simply give like this also, which means there is no depth of water. Okay, they can give exactly horizontally also, then also means depth of water is equal to 0. But here we have 1 meter. Here we have 1 meter water. So how much will be our H value? Your H value is going to be 6 minus 1, nothing but 5. So substitute NF and ND. 4 divided by 9. We will be getting the K value. Now you see, here they have given KH and KY, I mean KV value. Horizontal as well as vertical. See, for an isotropic soil, isotropic we know in all the direction it will be having same property. But whenever it is an anisotropic soil, we will be having different properties. Here we have the property of coefficient of permeability. We'll be having a permeability value at horizontal. We'll be having a different value at the vertical direction. Okay, something like this. Okay, now we have to calculate how much will be KV, how much will be KH. How can we calculate? That is the next concept that itself can be a 1 mark or 2 mark question. For an anisotropic soil, the equivalent permeability is equal to root of KH into KV, as simple as that. Okay, but from this directly we cannot know, we cannot calculate what is KH and KV. What you have to do for such question, whatever is the value you calculated here, K, then you check all the equations and which equation is getting which equation is satisfying. That's it. Okay, now one thing you have to properly check the unit. Here all the units are given in meter per second only. Okay, so this K is in meter per second, this H is in meter, so that the Q value we are going to get it in meter cube per second per meter. Actually meter square per second. Now the meaning is discharge per unit length. That's why meter cube per second per meter. Unit if you are checking meter square per second it will come. Clear? Now you just tell me which option is correct. Tell me which option you are getting correct. Yes, getting the answer. Which one? A and B. Is it? No. Which option is correct? Are you getting A as answer? Seriously? Let me check 1 second. I don't think you will be getting A. Everyone, please, how much you are getting K value? Can you please tell me how much you are getting K value? Okay, we'll check, don't worry. K is equal to 3.825 something now. Are you getting 3.825? Okay, very good. So K value is equal to 3.825 meter per second. Okay, if you are getting A, okay, let it be there. Now tell me, is there any other option? See, it can be MSQ, na? Which of the following is possible? That is the thing. Na? So it can be more than one answer can be correct. So you check it, properly calculate everyone. Those who are telling it is B is also correct, properly check into 10 raised to what? That is also important, guys. 10 raised to what? Okay. So this is wrong. Into 10 raised to minus 6 is also there. Right? If you are taking B option, properly check it. Into 10 raised to 5 it is. Okay, properly check it. Are you getting A? A is matching or not? Everyone please tell me. A is matching. Whether A is matching? Okay, A is matching now. Okay. So I'm selecting A. Letter B. So B is not matching now. B is matching, is it? Are you sure? Are you sure B is matching or not? It's 10 raised to 5, minus 5. Properly check it, don't make mistake. Properly check it, don't make mistake. Simply don't look at the first answer only. Right? Are you getting B as answer? Okay. Sorry. Yeah, okay, fine. I was thinking this as B, that's why. Okay, I'm sorry. Okay. So B also you are getting correct. Okay, fine. So what about C? C is 10 raised to minus 5. That's what I was thinking. So C is not coming. What about D? D is coming or not? Yes, Kasturi, just now I understood. Okay, thank you. Okay, I thought this is B and this is C. That's why I told you. Whether D you are getting correct or not? No? Okay. So can I write both A and B are correct? Yes, very good. I'm getting the right answer. Can I select both A and B as correct? Very good. The values are matching. The values both are satisfying, but A will not be the right answer. Only B can be the answer. Why? I mean. Sorry. I think I'm, 1 second, guys. Okay. A can be the answer. Okay. B also can be the answer, correct? But I mean, the satisfying value, but A will not be the answer. Only this can be satisfying. Why? You tell me why. I'm telling you the other answer is wrong. Now you tell me why. Why that will be wrong? Why that will be wrong? Only B we can take. Why? Very good. That's the point. Always remember, whenever we have an anisotropic soil, KH value will be always greater than KV value. This is very important point. We have KH value, the coefficient of permeability in the horizontal direction. We have KV value, the coefficient of permeability in the vertical direction. For an anisotropic soil, always in the horizontal direction, it will be more. So if you are checking the first option, option A, what you are getting, KV value is more than KH. This can be something tricky that they are going to ask. So I just wanted to let you know that concept also. That's why purposefully I have made that option. Clear? Is it clear? See, these are the portions you have to take care. They will just try to make some tricky question and just to make you deviated. Is it clear, guys? So now the only option which are going to satisfy the values and KH greater than KV will be option B. Clear? Everyone please comment. So our only answer will be option B. Henna? Everyone please comment in the chat box. Are you clear or not? Henna? Yes, very good. Understood? So this is one simple thing which you have to remember. Yes, very good. Now I'm just showing you some equations that you can easily study, very easy thing. Now suppose there is a soil layer and water is passing through it. Okay. So we have a coefficient of permeability value. We can easily take the flow Q is equal to K into I into A. You might have studied it many times in college exams and all. If we have more than one layer like this, then what to do? This K value will change. We have to take an equivalent K value. If the flow is happening and in the direction of flow, we have parallelly different layers. means which we are showing in the first case. Then the K horizontal value, we simply tell horizontally it is flowing now like that. That's why. Properly listen, they can simply give the figure like tilted also. Don't simply look at the figure like this. You have to check the how the layers are stratified. Layers are stratified like this and parallel to their boundary. Like that you can remember. Parallel to their boundary means the same figure. They can simply give like this also. Now, like this also they can give. Then don't think that it is vertical. No. Then it is also like this we have to take. Look at their boundary portions and the separation portion like this. Parallel to that water is flowing. Then we are going to take this equation. If perpendicular to their layers, if the water is flowing, then the equivalent K value we are going to take using the second equation. Okay. Okay, don't worry, Gunsaj, exactly the decimals and all you may not be getting exactly matching, but approximately you will be getting the same only 0.1 and not difference will be there. Otherwise, it will be clear. Okay, since I was getting doubt regarding how to take that NF value, simply this is why, okay, see if you have doubt, ask that time itself. It's difficult for others also if you are going back to the previous question. Now see, NF means how many flow channels are there. You just look at it. See, in transportation, we have studied space headway. No? If we have 3 vehicles, in between we have 2 spaces like that. But here we have a boundary at the top. We have a boundary at bottom also. So what will be having? If we have 3 flow lines, 1, 2, 3, flow channels will be having 1, 2, 3, 4. Understanding? So 3 flow lines we have like this horizontally. So this is one. Okay, let it be. This is one. This is the second one. This is the third one. So inner space 2, above and bottom, like that. That's all. Now 4. Understood? Clear? Yes. Now the next topic which we have studied. So that is one thing you have to remember. Then there is an equation like this: K into CD square E cube by 1 plus E into gamma W by mu. The very important thing is, if they are giving you for a particular soil, obviously void ratio and D10 is also known as effective size. C is a constant. Okay, that will be a constant part. These are soil property, and gamma W by mu is nothing but the what I can tell. If it is a water, then water. If it is kerosene, then kerosene, like that. Okay, this is water property, or we can simply tell that is fluid properties. Okay, this is nothing but soil property. So for a particular soil, K will be directly proportional to gamma divided by mu. Instead of gamma W, I can simply put gamma. If it is water, then gamma W. If it is kerosene, then gamma of kerosene. If it is seawater, then gamma of seawater, like that. Clear? I just want to let you know that this is not gamma of soil. This is the gamma of the fluid. Okay, so simply you can put fluid there. So this you have to remember. They can simply ask if you are taking a different viscosity, a different fluid of different viscosity, then what will be the, they can give you, okay, gamma also they can give you correspondingly. They can ask you what will be the coefficient of permeability. Then using this equation, you have to calculate. Okay, in anywhere, if you don't have any other data, you have to calculate the K value. Then there is an approximate equation. Generally, this equation they don't used to ask in GATE examination, because this is not that much accurate equation. But if nothing is available, only D10 effective size, okay, they will give you effective size called as D10, okay, corresponds to 10% finer. Yesterday we have, the last class we have seen first part D60, D60, D10, D30 and all the same D10. We can use this equation. Remember, if you are using this constant as 100, okay, actual general equation is K is equal to C D10 square. Okay, if you are taking this C as 100, that is best to remember. Take this as 100. Always your D value you should substitute in centimeter. Means if they are giving some 1 mm, then put 0.1 like that in centimeter. Then your K value will be in centimeter per second. Okay, like that. Now, this is something we have already discussed. Q is equal to area into velocity in hydrology, I told you. Discharge velocity is equal to, Krishna will come to that later, 1 second. Discharge velocity K into I, seepage velocity, discharge velocity divided by porosity. They will give you the void ratio, or they can give you the relative density, from where we have to calculate the void ratio, from where we can calculate the porosity and substitute here. Like that, they can ask you a 2-mark question. Understanding? So directly we can easily calculate this. Now if they are asking, if they are giving some point, if they are giving another point, they are asking how much time a tracer will take, a water particle will take from this location A1, or simply a location A1 to B1. Okay, from this location to this location, the distance they will give. If they are asking how much time that water particle will take from A to B, we know time is equal to distance by velocity, because velocity is equal to distance by time. So time is equal to distance by velocity. Which velocity we have to take? Which velocity we have to take? Should I take discharge velocity or should I take seepage velocity? Everyone please comment. We have to take, very good, seepage velocity we have to take. That is very important, that you have to remember. Yes. Okay, the same thing in hydrology also they can ask. Well, hydraulics portion here also. There also I told you this thing, I guess. Yes, Krishna Kasturidas is already giving you the answer. Very good. Inversely proportional we used to take. I will tell you later. Okay, don't worry. Now these things, direct equation. This is, you have to just by heart this thing. For coarse grained soil, we'll use constant head test, and for fine grained soil, we'll use variable head test. Okay, this thing you have to remember. Directly you can substitute the K value. For constant head test, Q is equal to K into I into A, which we have already seen. For variable head test, H value, head are going to be different. They will give you some head. The most important thing, whenever they are asking you variable head test, initially they will be giving you a head, which is H1. The final head, either they will tell you the final head is this much, or they will tell you the head is decreased by. If they are telling decreased by, then what you have to do? If they are telling decreased by, suppose decreased by 10 centimeter. Okay, if they are telling decreased by 10 centimeter, H2 is equal to H1 minus 10 centimeter, decreased by. Sometimes they will use the word decreased to some centimeter, maybe 30 centimeter, which means H2 is equal to 30 centimeter. Then don't take H1 minus 30. Clear, guys? Okay, this is something which in that examination hall, we were in tension. Okay, definitely we will be in tension. So by reading the lines, we may not be that much keen into the words they are using. So this is very important. Decreased by, decreased to. Clear? Okay, that's the only thing you have to remember. Then A and A, capital A, that they will give in the question. Definitely capital A value will be bigger. We have a soil here of bigger diameter. Area we are going to calculate. Either they will directly give, or we can calculate by pi by 4 d square and all. Okay, if they are giving a cylindrical specimen. Length they will give in the question itself. We can properly substitute everything. Remember, it is natural logarithm. Okay, or somewhere you will be seeing the equation 2.303 AL divided by cap 80, but then it will be log H1 by H2. That is also same only. Don't confuse if you are seeing an equation using 2.303. Both are same. Okay, clear? Clear, guys? Shear factor, it is nothing but D10 only, something related to C. And also we have a C. This is also a constant, which taking care the soil properties. Okay, shear factor, everything. Clear? Yes. Now, then this is the downward seepage and upward seepage. Very simple thing. Maybe in the last year GATE score booster session taken by Gilead sir, he has solved a question. Okay, based on this equation also. You can just practice, or as of now we have already calculated this. That's why I'm not explaining too much. Simply direct equation. Only thing is, for downward seepage, we have to use a plus value. For upward seepage, we have to use a minus value. In the sense, if we have, suppose we have a soil here, we have a soil here. If we are connecting piezometer somewhere, simply if you are connecting two piezometers somewhere, we'll be getting two heads. You know, suppose some head we are getting like this. So we'll be getting the difference between these two values, which is nothing but our head loss. We'll check this value also when we got that head loss. So if this is your head loss HL, this is the length you have traveled. This hydraulic gradient I is equal to that loss in head divided by L. That piezometer we can keep anywhere, at top or bottom, anywhere. We assume the I value as a constant value. Okay. So wherever you are connecting, you just check the difference between the piezometer's level. You take that value divided with wherever you have connected, the difference between that connected length. Okay. So you are going to get L. If they are asking, see, it can be sometimes bottom portion will be higher. It depends on the flow and all. If they are asking at any portion, sorry, any point at the Z meter above the soil layer. Okay, Z. If you want to calculate, if seepage is not there, we know that is equal to water table will be there definitely. Okay, gamma submerged into Z, we know. If seepage is not there, now if seepage is happening, if it is downward seepage, then we have to put plus I into Z into H gamma W. If it is not, if it is upward seepage, we have to put minus. That is why we are getting a quicksand condition sometimes. When we are going to get a quicksand condition, whenever this sigma dash is equal to 0. So if they are asking at what depth and all quicksand condition is happening, we can simply equate into this equation, then we can calculate it. Clear, guys? Okay, this is once again gamma submerged into H. If you are getting confusion, you can just if you are getting any, if you want any questions and all, you can comment in the comment box. Either I can take a question in the next part, don't worry, or you can just watch the last year video. There Sir has taken a particular question. Okay, that also you can watch, no issue. Clear? That are the things we have to check under permeability and seepage. Then yes, then I'm showing you. Yes, before showing the next question, I will just give you some points. After the points, we can just go to the next question. Okay. Next concept is the stress distribution. Whenever we have a point load, see, we have two equations, Bosniak equation, Westergaard equation. This time in the recently updated syllabus, they have removed that part, Westergaard equation. So this time they may not be asking it. At least you can just remember, it's simply equation only changing. Instead of 5 by 2, it will be 3 by 2. And here instead of 3 by 2 pi and all, it will be simply 1 by pi. And here also gamma Z, that also slight deviation is there that you can check. But this time they may not be asking. Generally, they don't used to ask Westergaard equation. They used to ask only Bosniak equation. Okay, they may not be mentioning like it is Bosniak and all. They will simply ask, by default, we are going to use Bosniak equation. Okay, nothing but if you have a point load, if they are asking at any depth, at any radial distance, what is the vertical stress at that point, we have to go to this equation. This is nothing but combination of these two equations is this one. Simply we can tell a constant Kb into Q by Z square. Okay. So what is that Kb? Kb is nothing but the equation which I have written here. If I'm combining it, we'll be getting that bottom equation. Equation is little bit complicated, something more you have to study. But if you are getting a lot of confusion or you are unable to by heart it, what you can do, you don't have to study the Westergaard equation, at least you study Bosniak equation. Okay, because high chance he is asking only Bosniak equation. Okay, now what is this Z and R? If you are taking any point, okay, if I'm simply drawing a vertical line here, just below the point of application, this is nothing but your Z value. Okay, this is your Z value at what depth it is from the ground, and this horizontal is nothing but your R value. Okay, means if it is exactly below the point of application, R is going to be 0. Or if it is on the ground level, Z is also going to be 0. Understanding? Is it clear? Okay, so this is KB equation. Okay, see, Gursaj, I have written here, na? Here I have written KB. Here I have written Z, sigma Z. Okay, if you are substituting KB here, you are going to get what? Q by Z square into 3 by 2P and 1 by 1 plus same. Clear? Is it same equation or different? Enough? Yes, very good. Okay, this is something you have to remember. Now, this is not that much important point. Simply I can tell, can just listen. If you are taking a particular horizontal portion, not that much important, but you can simply remember. If you're simply taking a horizontal plane, which is at Z meter, then the variation in that Z meter as R value changes will be somewhat like this. You will be getting maximum value here. Means at R is equal to 0. As R changes, then this sigma Z value keep on decreasing. Okay, contact pressure, everything I will tell you. Please wait, Naresh, I will tell you that also. Okay, this figure they can give as option, and they can ask you what is the exact figure. Like in transportation, we studied the Marshall graph, no? Like that, they can simply give which of the following is the correct graph representing the vertical stress. What is sigma Z? Vertical stress. Okay, variation on a horizontal plane. Horizontal plane means Z value remains same, but R value changes as we move left and right. Okay, this is the value. Now, sigma Z variation on a vertical plane means you're keeping the R value as constant. Suppose if I'm taking some particular R value, and in that sidewise distance means I'm applying the load here, I'm taking a particular distance here throughout, vertically down I'm checking. Z is varying, means yeah, like this a vertical plane I'm considering, and I'm checking how is the variation. I will be getting a variation somewhat like this. Means at some particular depth, you are getting maximum. Before that depth, after that depth, they are going to get lesser value. Okay. At some particular depth, we are getting maximum. Before that and below that. I mean, above that and below that, the value will be lesser. We don't have to by heart that. If you want, I can tell R by Z will be approximately equal to 0.817. Whenever that, see, R changes means this Z also will, I mean, the depth also will change. I mean, at the which point we are going to get, okay, corresponds to R by Z is equal to 0.817. So whatever is your R value, we can calculate Z value, R divided by this. Okay. Yes, the degree also we can calculate. That much in detail we don't require. 39.15 degree. Yes, very good. That much into depth they may not be asking. Okay. Right. Now, if I'm telling sigma variation exactly below the load, that is a special case. We have studied at any value of R, how can we calculate? Exactly below the point load. Then what we will do? The variation is not like this. The variation will change. It's going to be somewhat like this. Here we will be getting maximum. Somewhere we are going to get, it's almost going to be 0. We don't know at what depth. Later it will small value it will be going. So these three variation you simply remember. Okay, that can be asked which of the following is represents the true graph, okay, of a particular thing. Clear, guys? Okay. Now I will tell you, yeah, this is another equation which we have to remember for circular load. Okay, circular load means once if you are simply looking from the top portion, we are going to get a circle. Okay, just for understanding, I have just drawn a figure like this, like in a 3D. Okay, so if you are getting a uniform load on this circular area, at any particular depth, if they are asking what is the sigma Z value, you can use this equation. But this equation is little bit complicated and students used to make mistake. Okay, in the class also, students used to make mistake using this equation because see properly if you are listening it, 1 by 1 plus R by Z whole square you have to do. Then you have to take raised to 1.5 or 3 by 2. Then only you have to take 1 minus. Don't take 1 minus and then take the raised to value. First raised to 3 by 2. Then that answer you have to minus from 1. Then you multiply with I told you equal intensity na Q means kilonewton per meter square, like that, ton per meter square, some Q value they will give. Intensity of load, not the load value, it is the intensity of load. We are going to do a question based on this. Guys, tell me, are you getting difficulty in by hearting this equation? If yes, what you can do? Simply remember this equation. Q into 1 minus cos cube theta. Both are equal. But what is theta? If this circular area, circular area means if you are looking from the top, it will be having a radius like this. That's what I have drawn here. Okay. See, here we have a radius if I am marking. Okay. So this theta is nothing but, if you are drawing simply a diagram like this half angle is theta. Now, can you write tan theta is equal to, tell me what it will be? Tan theta equal to what? You tell me. Tan theta will be, yes, that's it, r by z. Na? If they are giving the diameter, then take the radius. Na? This is also theta, that half portion. Tan theta is equal to r by z. So from here, you can easily calculate what is theta. Tan inverse r by z. Na? Calculate the theta value, calculate the cos value, take the cube of that, 1 minus answer. In the online calculator, you cannot do 1 minus answer. So what you can do? Calculate cos cube theta first, take minus 1. You will be getting the negative of what is the actual. Simply you multiply with the q value, whatever you are getting, you just take it as the positive thing. That's it. Understanding, guys? In case if you are getting difficulty in the first equation, you simply remember the second equation. Both are same. You are going to get same answer. And always remember your tan theta is equal to this from where you calculate. Very shortcut. We can easily, using that shortcut equation, we can easily calculate it. Why I have written the first equation also? They can ask you which of the following equation is true for a vertical stress under a circular loaded area. Then if they are giving equations like this, then you should be remembering. Na? That's why I have written here. At least if they are asking, they may make difference in either in this square or in this raised to 1.5 or in this 1 minus. Either they put everything under raised to 1.5, or they will put, they will not be putting that r by z square, or they will put raised to 5 by 2, because in the Bose-Einstein equation we have studied 5 by 2. Here it is 3 by 2, like that. Okay, so such things they may make, such things they can just clear. They can deviate you from by giving such things. Okay, clear. Now we have to study something like Newmark's influence chart. See, now I'm just giving an introduction. Now we are then we'll be doing a question. Okay, Newmark influence chart is nothing but they will give all the values. I is nothing but influence factor that they will give in the question. N is nothing but if I am see any shape of footing. As of now, we have studied simply exactly particular shape of footing. Now, if you have any shape of footing, see something like this. Okay, top view. Then easily we can calculate how much will be the depth of, how much will be the vertical stress at a particular depth z. But in this equation, we are not using the z value now. So that z value will be already taking care under this figure. We are going to take different figures for different influence value I. We have different figures, so that they will give in the question what is the influence factor that they will give. N value also they will give. N is nothing but how many sectors are included. Simply if I am taking a figure like this, a square like this, how many sectors are included? 1, 2, 3, 4, 5, 6, like that. How many sectors are included? That is the meaning of that N. That also they will give. Only unknown portion will be this Q value. Okay, either they can give some load, they will give the area of the footing. So Q by area, you will be getting the intensity value. That's all. Very easy thing, that is you can easily substitute. Then we have an important thing. If we have a rectangular loaded area, I'm going to give a question for this also. For a rectangular loaded area, I have just drawn an the 3D view. In the sense, just imagine it's a table. Okay, if a table, if you're looking from the top, what you will see? A rectangle. And like this, you can see a table. Okay, now I'm removing the legs of the table. This is drawn just for your understanding. Now, if they are asking what is the vertical stress below the corner of, sorry, below the corner of a particular point. I mean, below any corner of a rectangular loaded area Z. Then we can use the equation I into Q. We are going to do a question based on this. As of now, take it simply. Clear? We can calculate only below a particular load, below a particular corner, either this below this corner or second corner or third corner or fourth corner, like that. We can use this equation I into Q. How we are going to calculate Q? They will give in the question, or they can give load value. We can take divide by area. We will be getting Q value. This I value we are going to take from a particular table. The table I will explain through a particular question. Clear? Now we will do a question. You just take this question. Yes, do it. Circular equation I have already told you. Just check the circular equation and substitute it. And tell me how much you are getting for circular. Properly check the question. What we have to do. Tell me how much you are getting for the circular one. Substitute the equation. Either you can use that 1 minus cos cube theta, or you can directly substitute in the other equation. First you calculate the circular one and tell me what is the answer below a circular loaded area. Very good. Very good. Very good, Krishna. See, what will be the Q value, everyone? What will be the small Q value? 4 meter dia. Na? So 4 meter diameter means dia is 4 meter. What will be the Q value? Load is given as 1500 kilonewton. Intensity of loading it is, na? So pi by 4 d square. Okay, always remember, convert into Q value. Don't directly take 1500. You will get wrong answer. Either you substitute it, or you can simply calculate how much will be theta. Tan theta is equal to R by Z. R is nothing but the radius. 2 divided by 10 meter they are asking. So you can calculate the theta from there. Then finally you can calculate, right? Theta will be is equal to tan inverse 0.2. Calculate whatever it is. Directly click on cos in the online calculator. Take the cube of that. 1 minus that answer. You can simply take minus 1. No? Then multiply with 1500 into 4 divided by pi divided by 16. It will come like that. This pi by 4, that 4 will go up. How much you are getting for circular loading? Yes, very good. 6 point. All are getting the same answer. All are getting same for the circular one. Everyone please comment how much you are getting. Exactly. Yes, very good. Getting the answer, everyone? Yes. Either you can do with that equation or the first equation, anything. Both are going to give you the right answer. But in online calculator, it's better to do using the theta equation. Okay, otherwise so much of brackets and all you have to put. Okay. Now coming to this is what I told you. What they have given. The foundation is, see, we have to, see, first of all, we have a circular diameter foundation. Later we are replacing with a square foundation of 4 meter side, which means it can be either rectangle or it can be a square to use that particular equation, which I have shown you last. You know? So everywhere it is 4 meter. Now what we have to calculate, they are telling at the center at a depth. So if I'm just drawing like this, as of now, we know only one thing. At the corner, at a particular value of z, we can calculate. Now they are asking at the center, at the value of z, what to do? What we can do? If they are asking at the corner, directly we can apply the equation. If they are asking at the center, what we can do? We can split this square into 4 different squares, so that now this point is going to be below the corner of 4 different small squares. Understanding, guys? If I am splitting this square into 4 different parts, okay, either it can be a rectangle or it can be a square. If I am splitting into 4 different parts, what we are getting? Now that point has become at the corner point of 4 different squares. You know? If it was a rectangle, then 4 different rectangles will be getting of equal area. You know? So this is having 2 meter, 2 meter side. This is also having 2 meter, 2 meter, everything like that. Clear now? Clear? Now to calculate the stress at that point, what we can do? First, we can consider one particular square, and now we can calculate what is the value of stress at the corner point of this particular rectangle, or square. Similarly for the second one, third one, or fourth one. Okay, Gursaj, you just directly substitute how you are getting 6.819. I have already shown you the equation now. You just have to substitute there, that's all. Or like this, you can calculate theta value. From here, you can just directly take cos cube theta into q. You are going to get that answer. Directly, I have written here. Clear? Yes. Understood? So how can we calculate this? This is why we require the table. So what it is written, m value, n value, and influence coefficient. That's we have to check. L by z means length by depth. Why we are writing L, length and all? In general, if they are giving a rectangle, then by splitting we'll be getting a length and width. No? So this we can take it as length till here. This we can take it as width. So now can you tell me what will be for our figure? What will be L by z? Length by z? What will be length by z? Means for each rectangle. So this is 2 meter divided by 10 meter, 0.2. Similarly, breadth by z is what? B by z is what? That is also 2 because it is a square. If it was a rectangle, we are going to get different value. We don't care which is m, which is n. Okay. Here we are getting 0.2, 0.2. So corresponds to 0.2, 0.2. Which value you have to take? Which value you are going to take? Yes, 0. First one. By mistake, don't take 0.4, 0.4. Okay. Because we are already splitted. Now, remember one thing. If the m value is, for example, 0.5, n value is 0.2, you need an answer. For example, I'm telling. Okay, this is what you require in the question. For example, but it is not available in the question. But they have given 0.2 and 0.5. Okay, let it be any combination they are giving. Then what you will do? This is given. Then what you will do? In the sense, in the question, suppose we require a combination of 0.5 and 0.2, we require what is the influence value. But that is not given in the question, but they have given 0.2, 0.5 combination. Then what you will do? Will you take 1 minus that given value, or will you take as it is? Will you interpolate? Don't do anything. Okay, this combination only you have to check. Understanding? This combination only you have to check. In the sense, if they are giving a table, for example, if I'm telling there is a rectangular area, okay, and this is suppose 6 meter, this is 4 meter. Okay, now if you are splitting it, what you will be getting? This has 3, this has 2. Okay, now what we require, suppose that is equal to 10 meter. Okay, what we require, the combination of 0.3 and 0.2. We require this. But in the question, they have not given this, but simply they have given a combination 0.2, 0.3 is equal to, let it be some value, 0.02, something. Okay, 0231. Then what you will do? No need to do anything. Simply take as it is. The M and N combination only you have to check. Clear? Okay. This may not be this value. There is a particular value for all the M and N values. Okay, it is already predefined values are there. Is it clear, guys? We just check the M and N combination. Okay, so here 0.179. So substitute there. Sigma Z is equal to 0.0179 I into Q. We have already written that equation. I have shown you where it is. 1 second. See here I have written that equation. See I into Q. Q value we already calculated 1500. So this Q value is nothing but 1500 divided by. Now tell me what is the answer of area? Is it pi by 4 d square? That's it. Now it has become a square, na? So 1 second. So as of now, what we calculated? Yes, 60. And the Q value. Now what we need to do, guys? What we need to do? 1 second. Yes. What will be the intensity of loading? Should I take 1500 divided by 4? Or should I take 1500 divided by 16? Which is correct? 1500 divided by 4 or 16? Don't make mistake. Don't take 4. It will be 16 only, okay? Because the total area is 16 meters square. Our load of 1500 is came on. Load of 1500 is came on 16 meters square. So what will be the intensity of loading here? Intensity of loading will be 1500 divided by 16 meters square. So everywhere on this 4 meter square small rectangle also you are getting the same intensity. Okay. So tell me how much it will be. Total value sigma z is equal to. You will be getting some part. Is it the final answer? Is it the final answer? No. Like this we have different squares. So for each square we have to calculate by taking the I value and we have to add it. But see here, whenever we are, if it is at the center, if it is the rectangle or if it is a square, we are getting same portion. So directly what we can do? Directly our sigma z value will be equal to what we have to do? No need to add it separately. Multiply with 4. That's it. Understanding, guys? Are you understanding? Now tell me the value. Tell me the value sigma z. Multiply with 4 and tell me 6.7125. Okay, thank you. 6.7125 kilonewton per meter square. Right. Getting? So what is the question? What is the change? No? What is the change happened? 6.819 it was. Now it was became 6.7125. So how much is the change? How much is the change? 0.17. Huh? 0.107. Okay. Kilonewton per meter square. That's it. There is a small change only, na? Yes, 10 something. So which option I have to select? Which option I have to select? Yes, very good. Option A. Clear? Is it clear, everyone? Properly check it, okay? The only thing they can make here is one thing is by like this. I have already given you the load. If they are giving you the intensity, you may not make mistake. But if they are giving you the load, you may make mistake here. Okay, so by dividing, take the total area. That's it. That is the only thing. Then if it is a square, then the combination only you just check M and N. If they are giving opposite, then also it will be the same value. Clear? Right. So those things you remember. Now, yes, take this question. One second, before going into the question, I will just show you the equations of settlement and everything. I will tell you, contact pressure, those things I will show you. Just take a screenshot. I hope you have already studied consolidation. There are important equations. We are going to use these equations in the question. If you want, you can just take a screenshot or just go through these things. Again, I will take these equations and I will show you this. For ultimate settlement, we have different equations. Any equation you can use. If they are giving you the volume coefficient of volume compressibility, we can use the first equation. If they are giving you the change in void ratio, total thickness, initial thickness, this H is nothing but the initial thickness. Okay. Then also we can use the different equation and calculate what is the final settlement. SF, I mean SF by settlement final. Okay, final settlement. Sometimes in the material you will see delta capital H, or you can use this equation H into CC. CC is nothing but compression index. Compression index is nothing but if you are actually increasing the effective stress, void ratio decreases. We are going to get a curve like this. If you are taking the slope, okay, somewhere E2 minus E1 divided by effective stress sigma dash 1 minus sigma dash 2, we are going to get this guy. Okay, nothing but coefficient of compressibility. This is not coefficient of consolidation. This is coefficient of compressibility. If you are taking the y-axis in terms of log scale, then we are going to get CC, nothing but compression index. So if you are drawing in log scale, we are going to get a straight line so that CC value will be always a constant, but AV value will keep on changes. If you are taking the values here, it will be a particular value. If you are taking a slope somewhere else, AV will be different. But CC value will be always a constant. That CC value only we are going to substitute here. If CC value is not given, either they can give a graph like this from where we have to calculate, or they can give that it is a remolded clay or undisturbed clay, from where also we can calculate. I'm going to give you a question, you will understand. Okay, so these portions also you remember. Either they can give you the AV value, E0 value and all, and they can ask you what is the what is the final settlement if the increase in effective stress was this much happened like that. Okay, we can easily calculate. Now here I have written sigma final minus sigma initial. Effective stress, this is final means what? The sigma F value I can also write it as the numerator, the denominator value plus change in effective stress. Initial value plus change in effective stress is nothing but final value. So these things you remember, we are going to use this. Then a very important thing, time factor, which is denoted by CV, which is denoted by TV, T suffix V, time factor. Equation is same, CV into T by D square, where CV is nothing but our coefficient of consolidation. T is nothing but the time that we are taking. D is nothing but the drainage path. Very, very important thing. I will tell you when we are discussing the question. Okay, let it be there. CV value, if they are not giving, CV is what? Coefficient of consolidation. What was coefficient of compressibility? That was AV that we have drawn in the graph. This is coefficient of consolidation. If they are not giving, coefficient of permeability divided by MV. We have seen in the previous here, MV, coefficient of volume compressibility, then into gamma W. Okay, nothing but our water. Okay, so this equation is same for any degree of consolidation that you can equate to another equation. What is that equation? If the degree of consolidation is less than or equal to 60%, we have a very simple equation, pi by 4 u square. Very important thing, u should be substituted in terms of decimal. Means if it is 50% consolidation, this u should be 0.5. Means pi by 4 into 0.5 square, like that. If degree of consolidation is 40%, then pi by 4, 0.4 into 0.4, like that. Okay. Now, if it is greater than 60%, we have two equations. You can either study the first equation or you can study the second equation. I personally like the first equation. Okay, any equation you can study, both are same. Only difference is if you are studying the first equation, here this u value is in percentage. Means if the degree of consolidation is 80%, you have to substitute here 100 minus 80. Whereas if you are using this equation, here it should be decimal, means 1 minus 0.8, like that. Okay, no need to get confused because of the equations. Anyone you can use, both are going to be same. Clear? If it is 60, then both answer you are going to get almost the same. Okay, now, but we prefer more accurate value will be we are going to take for pi by 4 u square equation. Clear? This is something you have to remember. Then regarding immediate settlement and all, I will tell you later. We can do a question now. Okay, using the question we can understand the equation more, I mean, in a better way. So you just take the question, understand what is given. It's a lengthy question, means I have split it into 3 parts. Each part can be a 2-mark question, like that. Okay, any of these 3 can be a 2-mark question. Properly go through it and understand what we have to do. I'm giving you a few seconds to understand the question. We have to calculate the time. You know? So whenever they are asking how much time it will take, see how much it will take means in days, you know? Means how much time. In consolidation, whenever they are asking how much time it is taking for some particular degree of consolidation, always remember we have only one equation for calculating the time, nothing but TV. Yes, very good, very good. TV, you know? What is the equation? CVT by d square. So if they are asking how much time it will take, either they can give you the TV value and D value and CV value, then they can ask you the T value. Or what they will do, they will not give you the values from the given data we have to calculate. Okay, now can you tell me, they have not given the time factor in the question, no? Are you seeing any time factor is equal to 0.1, something like that? Nothing. Now what we can do, either I can use the pi by 4 u square equation, or I can use the second length equation. Which equation we can use? Very good, very good. Which equation we can use? It is 40% consolidation, which means it is the first one. TV is equal to pi by 4 u square. And now less than 60% it is. So tell me how much you are getting TV value? 0.1256. Okay, thank you. And now what we got? The left hand side we got. You know, 0.1256 is equal to CVT by d square. Now, if they are asking how much time it may take for 70% consolidation, then it is greater than 60. We have to use the other equation and calculate the TV. Clear? Okay, how we are using the TV equation? Clear, guys? Now, this right hand side is common for any degree of consolidation. CVT by d square is common. Now check whether they have given any coefficient of consolidation in the question. No. Whether they have given any d square in the question? Yes, d we can calculate, nothing but 24 centimeter. Now CV is also not given in the question. If CV is not given, then we can calculate using K divided by gamma W, that equation, divided by MV. That is also not given, then what we can do? That is why they are giving a sample calculation. If you are taking, see, the total depth of a layer is 10 meter. Enough? Then what we are doing? This is another option they can do. Without giving the data, they can give the data of a sample, representative sample. What is that sample? We are taking a 3 meter sample from this, and we have calculated that it has taken for 40% of consolidation, it has taken 35 minutes. Why they are giving this? Because they don't want to give CV value in the question. If they are giving CV value directly, we can calculate it. Okay, instead of giving CV, if they are giving CV value, direct calculate. If not, look for this data. They will be giving you a sample. Okay, result of a sample taken from our soil. Okay, they have given that for 40% consolidation, we have taken 35 minutes. Enough? Now you look at it. We know the equation TV is equal to pi by 5 u square for 40% consolidation. Enough? They have given that it has taken 35 minutes for 40% consolidation. So simply it is the same thing now, same data, same soil. So for a same soil, CV value will be same. Coefficient of consolidation is less than 40%. So we can use the same TV value also for the clay sample. So for this sample, TV value is same. CV coefficient of consolidation will be same because it is the same soil sample. And what is remaining? T and D are remaining. What we will be getting? What we'll be getting? T directly proportional to D square. Clear? Clear now? Now what we have taken? A 3-meter sample. Now look at it. What they are giving? We have a clay layer of 10 meter. From that we have taken, see, 2 sand layers of 3 meter thickness. We require 10 meter clay layer is there, and we have sand here which is of 3 meter. We have sand here which is also for 3 meter. Where you are going to use this 3 meter? Where you are going to use this 3 meter? Very good, not used. That's it. That is just for confusing you. We don't require that thing. We require only our layer. That's it. What we require is which type of soil it is. If it is a sand, sand is permeable. Definitely, we'll be having drainage on both sides. So D value will be H by 2 is equal to 5 meter. Suppose on one side, if they are giving that on one side, it is a complete rock portion. Suppose here. Okay. Suppose here we have a rock portion. Then we'll be having drainage only in one side. Then D will be equal to 10 meter. If both sides we have drainage, either they will give that it is a double drainage layer, or simply they will tell that both side it is sand, or they will tell that both side we have permeable layer. Okay. Or they can tell one side it is permeable, other side it is impermeable. If both are permeable, take divide by 2. If only one side we have permeable, take exactly what as it is. Correct? So here they have given both side we have sand. Yes, correct, exactly. Which means we have two-way drainage. Okay. So for the particular clay layer which we want to calculate is T2. Let it be. So T2 is there. For the sample, it has given 35 minutes. Can you write that is equal to D of the layer? What is the D of the layer? So T2 by T1 is equal to D2 square by D1 square. Now, T directly proportional to D square. So for this soil, we got D is equal to 5 meter. So 5 square divided by. Now 35 minutes is corresponds to our soil sample of. No, sorry. This was not, 1 second. They are asking for 24 now in the question. Sample is 24. Okay. 1 second. Okay, yeah. 24 centimeter is the sample thickness. So what we have is the 5 meter soil. So we are putting 5 square. I mean, not 5 meter soil, 10 meter. So D is equal to 5, like that. Okay. So 1 second. I think I made some mistake. No, nothing. So what it will be? Tell me. Divide by what? Divide by what square? 24 centimeter. Can I substitute 12 square? 24, no? 24 centimeter. So can I take 12? Very good. 0.12 square. Okay. Unit is also very important. 5 is in meter. So 0.12 square. Is it clear, guys? Is it clear? What you are getting in T2 will be then in minutes, because here we are converted this into meter. Meter square and meter square will get cancels. Whatever you are getting T2 will be in minutes. So tell me how much minutes you are getting. Tell me how much minutes you are getting. Everyone please comment. Are you getting the same answer which I got? Are you getting the same minutes? Yes, thank you. Now how many days it will be then? How many days it will be? If I want to calculate in hours, then divide by 24. I mean, sorry, this much minutes. So this much minutes, yeah. This much minutes I want to convert into hour, means divide by 60. I want to convert into days, divide by 24. Tell me how much it is, everyone. How many days? 42.197. Is it? Everyone please check it. 42.19. Are you getting same? Understanding, everyone? Yes. Okay. So always check it. If they are giving you the TV value, then directly we can calculate it. I mean, if they are giving you the CV value or TV value, TV they may not be giving you, then they don't have to ask anything. Now directly we are getting. So look at CV value. If CV value is not available, then look at whether they have given any sample or not. Definitely it will be there. Okay. If that is also not there, look at K value. If they have given the K value, once again, if they have given the K value, where I have written the equation I have shown you now, see, MV equation or CV equation, they can give K value, MV value and gamma W value. If they are not giving MV also, we can calculate it from here. So like that, you have to go. Okay. So according to the given data, you have to calculate. Now the second thing, we may take some 5-10 minutes more. How much more time it will take for 80% consolidation? So what you have to do? I told you the only equation we have to check the time taken is TV equation, CV into T by D square. Now they are asking for 80% consolidation. Now can I use this equation? Pi by 4 u square? Can I use the pi by 4 u square equation? No, because it is 80% consolidation. So if it is 80% consolidation, what we have to do? Till here it is same. TV is equal to CVT by this is common for everyone. The second equation I can use it for greater than 60%. Which equation I have to use? 1.781 minus 0.933 100 minus u. That equation. Okay. Any equation log 100 minus u. Any equation you can use. No. Any equation you use and calculate and tell me what is the answer. If I am using that one, 1.781 minus. Okay, you can calculate using the other one also. Once I'm using this, it should be 80. How much you are getting? TV value. Everyone please comment and let me know. Are you getting the same answer? Are you getting the same answer? Yes, getting now? Okay, good. Now see what you can do now. What they are asking for 80% consolidation. How much more time it will take? So same clay layer. Same layer means what? D is same. CV is also same. Everything is same. Only thing is we have to check. We got right now corresponding to a TV of 40%. We got 0.1256. TV was 0.1256 corresponding to a time of how much days it was? 42.19 days. 42.19 days. Now what they are asking? See, we understood. This is a particular type of soil. For the same soil they are asking. So CV is constant. D is also constant for a particular soil. So TV will be directly proportional to time. Okay, simply we can take like that. Now they are asking what will be the time for the next one if TV is equal to, as simple as that we can calculate now. So T2 by 42.19 will be equal to 0.567 divided by 0.1256. Correct now? Now you tell me how much will be this T2 value? How much time it will take for 80% consolidation? How many days? Everyone please comment how many days it will take for 80% consolidation. Are you getting this answer? 190 point. Take your time and tell me. Yes, 190.5 approximately. It depends on how accurately you are taking the data. 42.197, I guess this accurate data is. We may take some 5 minutes more only, or we are about to end that. 190.52. Correct now? Around 190.5. Okay, enough. Depends on how accurate you are taking the days values and all. Now, what is the question? Is it my answer? If they are asking how much time it will take for 80%, then 190. That is the answer. How much more time it will take? Which means what? We have already calculated 40% as the first question. Now for 80%, how much more time? Then how much more time it will take? How much more time it will take? That's it, 148. Huh? How much more time? Calculate and tell me. 148.3 something. Correct? Yes. So round off to integer, no? Round off to integer. So everywhere you can round off to integer. This answer will be 42. This answer will be 148, like that. They will give a range. Okay, don't worry, because log calculation, so many things are coming now. Is it clear, guys? How you have to check the data, how you have to use the equations? Are you getting the confidence? Are you getting the confidence? Okay, yes. Now what is the last one? Coefficient of consolidation. How can we calculate? Very easy. Any equation you can substitute. Either you can substitute this one, 0.125, then correspondingly you substitute what is the t. Or you can substitute this one, 0.567, correspondingly you have to substitute the t value. That is the only difference. Clear? If you are putting 0.125, 1256, then the time will be 35 minutes. Correspondingly, d value will be 12. Or you can put the clay layer thickness also. Okay, any equation you can substitute. Whatever it is, you will be getting the same answer. How much you are getting, you calculate yourself. Any t value you substitute, corresponding capital small t you substitute, corresponding d value you substitute, whichever equation you are using, finally you are going to get 740, around 740 centimeters square per minute. One second. No, 0.51 something you are going to get. Everywhere we have centimeter and all now. Either you will get 0.5143 centimeter per minute. So in 1 minute we have this much. Then 1 hour I will be getting this much in this much centimeter in 1 minute. Sorry, in 1 hour. This much centimeter in 1 day. So that will be equal to 740 approximately. Are you getting centimeter square? Okay. Are you getting approximately this much? Are you getting approximately this much? Everyone please comment. Yes. Getting now? Everyone please comment how much you are getting. Any value you can substitute. Any TV value and any corresponding small t and d. Okay, all are getting now? Any doubt? Yes, very good, very good. Kushbu, Kasturi Das, Krishna, all are getting? Yes, very good. Yes. Is it clear, guys? Okay. Now I want to give you one more question of consolidation that we can do in the part 3. Okay, don't worry. Okay, one simple thing I'm telling you. So we have a question here for distribution and all that I will give you in the part 3 as the first question. Some point I'm telling you here just within 1 minute, then we can finish it off. Yes, very good. Very good. All are getting 714 around? Yes, good. Now see, they can ask you the immediate settlement. As of now, we have studied the consolidation settlement. Just some theory point I'm telling you can be asked for numerical. Just within 1 or 2 minutes, we can finish this. Okay, consolidation, one more question I'm going to give you, that will be in the part 3. Part 3 will be our last session. Okay. Now immediate settlement, direct equation substitution, everything I have written here. The most important thing you have to check here is what is the E and mu, Poisson ratio and modulus of elasticity of soil. Just to confuse you, what they will give you a footing. Okay, they will give you a footing, either circular, rectangular or anything. Okay, or strip footing they can give. Whatever footing they are giving you, they may give you the Poisson ratio of concrete of this particular footing. They can give you the modulus of elasticity of concrete also. Don't use that. Below we have soil, so we have to use the Poisson ratio and E of soil. If you are getting confusion, you can just put mu s, or simply remember it is of the soil. We don't have anything for the, for the particular footing, we don't have to take the E value and the mu value. The only thing we are taking for the footing is nothing but this B value. B value is nothing but the least lateral dimension. What do you mean by least lateral dimension? If it is a square footing, it is the width. If it is a, if it is a rectangular footing, it is the width. If it is a square footing, same, only one thing. If it is a strip footing, also they will give a width. That's it. If it is a circular footing, then that is equal to diameter. Instead of B, we can substitute diameter. Understanding? That is the only thing you have to remember. The other thing is Q. Either they can give some load value, some 1000 kilonewton. If they are giving some load value like this, area of the footing we have to divide, then put it as Q, intensity. Clear? Clear? What is intermediate settlement or elastic settlement? Both the names you should remember. They can ask you any name. The very important point is that only influence factor they will give in the question. Okay, don't worry, they will give. One point you can remember, for a flexible footing, whatever is this influence value, for the same dimension of rigid footing, the influence value will be, okay, here I have 1 second. Okay, look at the first sentence. For the rigid footing, for the same dimension of flexible footing, for the rigid footing, I value will be less, 80% of that of the flexible footing. So since I value is 0.8 times as that of the flexible footing, what they can do, they can give some elastic settlement of the flexible footing, and they can ask you what will be the elastic settlement of the rigid footing. What we can do, if I is getting decreased by 20% or to 80%, nothing but 0.8, S value settlement also will change into 0.8 times. Is it clear? Yes, Naresh, I will give, don't worry. Okay, PDF and everything we can give, don't worry. Understood? Elastic settlement, influence factor they may give. Or they can give you the influence factor of the flexible payment. From there, we can simply multiply with 0.8, then we can substitute the value for the rigid payment if they are asking. Clear now? Is it clear, guys? Now, okay, one more point I want to tell you regarding settlement and contact pressure under flexible footing and under rigid footing. That I can discuss. I told you one more question I have to do for consolidation. So after discussing that consolidation question, I will tell you how the contact pressure and settlement changes below a flexible footing and a rigid footing under sand condition and clay condition. Generally, it's very difficult for the students to remember those things. Simply will remember. Okay, don't worry. That we will discuss at the starting of the part 3. And in part 3, we'll see the slopes, stability of slopes, then what I can tell, the earth pressure theory we have to see, then the bearing capacity of foundation we have to see, pile foundation we have to see, along with the lateral earth pressure. Okay, so these things we have to see, the shear strength also we have to study. One important thing I'm telling you, till this portion, consolidation also, that one question I will do in the third part. Till this portion, you just be confident till this much chapters. Around 60 to 70% marks will come from this portion. Okay, if you are very much worried about shear strength or pile foundation, under rimmed pile, those things, you can just keep that in the side. Don't worry. If you don't know that, it's okay. You will lose some 4 marks only. The remaining 10 marks you can easily score from this much portion. Okay, but if you are attending the part 3, definitely you are going to score around 2-3 mark in the remaining portion also. Don't worry. We are going to discuss so many things. So much of complicated thing you don't have to study at this location, this time. Okay, now we don't have that much time. So just skip that complicated portion. From wherever you can score more, you concentrate on that and make sure that you are going to get that 2 mark in the examination. Okay, so the remaining portion we are going to see in the part 3, right? So yes, that topic also we can discuss, Krishna, don't worry. Okay, so why then? Thanks for joining. Subscribe the channel and click on the bell icon also. You will be getting that notification for upcoming live sessions. The remaining portion we are going to see in the part 3. Okay. So I hope you have enjoyed the session. If you have enjoyed the session, please give your feedback in form of likes and comments. Share the video linked with your friends also. That's it. Okay. Bye. Thank you. Thanks for joining. See you in the next part. Bye.